So you will be able to access the recording through our website following the event. Parallel to that, just a quick reminder or a friendly remark to please mute your microphones and turn off your cameras so we ensure a stable connection, or at least for those who are not speaking at the time. As we proceed with the event, we will also have the chat functionality available. So if at any point you feel the need to ask or raise any questions to any of our speakers, please feel free to do so, and I will keep an eye on our chat as we proceed. Before we start with the content of today's final conference, just a quick overview and a rundown of the program. So first, welcome and introduction, followed by an opening statement by Mr. Marshall Hessia, our project officer from DG GROW, who has joined us today. Then we will dive into the 3DP PanEU project results and look at what we've delivered over the course of the past 2 years of project implementation. Followed up by several presentations from some of the SMEs or beneficiary SMEs who have had their innovative projects funded through an open call for SMEs. They will present information about their projects and highlight some of the innovations that they've been able to produce and some of the innovative methodologies that they've been able to incorporate within their projects. We will have a short break in between our SME presentations, during which we'll also show you some videos, but more on that later. And then in the second half of our conference, we'll have an expert discussion focusing on accessing specialized expertise and infrastructure through interregional collaboration, followed up by a presentation of the 3DP PanEU report on additive manufacturing from our project partner IDEA Consult. And then at the very end, we will be looking towards the future, looking at what new functionalities and possibilities will be under the 3DP PanEU matchmaking platform. Having said that, and before moving to the rest of the content, I would like to pass the floor to Mr. Marshall Hessia from DG GROW.
Thanks, Tim. Good morning, everyone. Very pleased to be here. Really just to set the context for this project, as you know, you may know, it's a European Parliament pilot project, really looking to focus to take advantage of the additive manufacturing opportunities for SMEs that really don't always benefit from this. So in a broader policy perspective, the importance of encouraging innovation, as you know, is something, particularly amongst SMEs, is particularly important, something that the EU has focused on for a number of years. Of course, this has become more critical in the face of increasing competition, international competition, and the difficulties presented by COVID. So in this context, adjusting to restrictions in supply chains, the market difficulties has meant that new processes and technologies have been needed to meet expectations, as well as to improve skills and capabilities to adapt to the new business circumstances. The European Commission, in again a very broad context, adopted an updated EU industrial strategy in 2021. It built on the 2020 industrial strategy and focused on strengthening the single market, addressing technological industrial strategic dependencies, which are something we're working on quite a bit now, and the importance, of course, of supporting green and digital transitions for all companies, not least SMEs. It complements regional initiatives, for example, the Smart Specialization Platform and support for innovation under Horizon Europe and indeed the Single Market Programme. It focuses increasingly on industrial ecosystems, which provide a bottom-up approach, which can take account of specific system-based differences and different business models. By adapting to horizontal and vertical links amongst a variety of economic actors, this can again improve and stimulate innovation and help SMEs keep up to speed with the rapid changes within their sectors. Additive manufacturing fits well in this framework, and although the project was started before the pandemic, the notion, the need to have a rapid response to specific manufacturing needs is something that was already becoming increasingly important, and this project looks to take advantage of that. We'll see today, and we'll run through the various initiatives, but the project, as Tim mentioned, focus on additive manufacturing, test and demonstration facilities, and look to match through the platform available equipment and services, particularly for SMEs. And indeed, we've had, you will hear from the SMEs, the ones that have benefited from this kind of support through the online platform. And we will hear from these 10, well, not all of them, but there were 10 SMEs that benefited from support. And indeed, we will also hear towards the end of the day a gap analysis report, or the results of the gap analysis report, which was also funded under the project. Anyway, over to you, Tim. I'm looking forward to hearing all about this, and I wish you all a very good conference.
Thank you very much, Marshall, and thank you for your words and for indeed setting the seed for today's event. Having said that, we will move into the first block, which focuses on 3DP PanEU, the project, as well as what we've delivered over the past couple of years. So as mentioned, the 3DP PanEU project was a European Parliament pilot action. It was a project which started in 2019 with the goals and aims to not only foster awareness, knowledge, and uptake of 3D printing, but to also promote the access of SMEs to high-quality additive manufacturing and 3D printing services, infrastructure, and expertise. To reach those goals, or to meet those goals, the project focused on several key activities, or at least 3 main activities. The first of which was launching and managing the 3DP PanEU matchmaking platform, which has been up and running and live for around 1.5 years, almost 2 years now. And I'll present a bit more information on that later, just to give you some facts and figures about the platform itself. We've also launched and managed a call for SMEs to financially support them in their industrial demonstration and validation projects. We'll have presentations from 4 of those today to give you more insights into the activities which they've conducted and the goals that they were trying to achieve by incorporating additive manufacturing processes within their projects. And finally, and we'll have a presentation on that as well later today, the analysis and drafting the report on the additive manufacturing landscape in Europe. So firstly, as mentioned, we had our 3DP PanEU matchmaking platform launch. This was there was a lot of development time which went into creating and setting up the platform from our consortium of partners, and not least of which Asterion Europe, which was our IT partner. They played a key role in developing, launching, and keeping the platform up and running and live. The platform itself was launched on the 23rd of March last year. So we've, as mentioned, been up and running for, let's say, 1.5 years. And since the launch of the platform, we've seen several key growth developments, let's say. So first and foremost, obviously the goal of the platform was to bridge the gap between supply and demand between the available services, equipment, and infrastructure which we have within Europe, and matching that to SME needs, or at least SME development needs, where there would be an added value or a role to play for additive manufacturing. So a large focus of our platform was placed on populating the platform, ensuring that we have a good coverage and a good reach out to those different actors based in Europe who offer additive manufacturing services to third parties, and particularly SMEs. Since the launch of our 3DP matchmaking platform, we've been able to attract a community and a population of over 300 individual facility centers who are registered and are active within our community. And those 300, or over 300, I should say, together represent a large number of different services and equipment which is being made available. So we have over 900 pieces of equipment and infrastructure registered to our platform, as well as over 1,200 services related to 3D printing. This not only gives us good insight into the availability of different additive manufacturing services and equipment across Europe, but obviously the main goal was to bridge that gap between SME needs and services which are being made available. So to address that need, obviously the matchmaking platform went beyond simply having different organizations registered and creating an overview of which organizations provide services, but we developed several matching tools. We developed a basic matching tool, which was less complicated and less complex in terms of technical specifications, or at least from the SME side, what would be needed for information. But we also developed a more in-depth matchmaking tool, which would allow an SME to very clearly specify their 3D printing need, or at least their additive manufacturing need, diving into different criteria, dimensions such as the size, the materials, the printing quality, etc. And these tools would allow the SME to get an insight into which facility centers based in Europe would be able to address or meet the search criteria of the SME. We realized that obviously this platform filled a need, or at least there was a need for such a platform to exist, because in the first year alone, there was an average of around 1,600 platform users per month. As mentioned by Marshall during his introduction, over the course of the 3DP PanEU project, we were also hit by the COVID-19 pandemic. This impacted the project in and of itself, but obviously the impact was far greater than our project, with many different supply chains within Europe being negatively impacted, or at least being disrupted. Within this disruption, we noticed, and there was a trend to look at additive manufacturing to overcome some of these supply chain issues, and to use our platform, or at least to increase the added value of our platform. We developed a special additional tool on the 3DP PanEU website, which was a COVID-19 response initiative. Through this portal, we broadened the scope of the 3DP PanEU matchmaking platform, which is focused on demonstration and validation services. And we opened it up to also accommodate more traditional, let's say, 3D printing requests from SMEs. Once we introduced this platform, we had a total of 124 facility centers who registered to this tool. This was an open offer to facility centers to make use of. But through this additional tool that we integrated in the platform, we hope to at least create added value to our platform and to its users. As mentioned, we also launched and managed a call for SMEs to financially support SMEs in their industrial projects. We launched the call itself on the 15th of April and closed on the 31st of August 2020. So we were open for about 6 months. And the aim of the call and the projects themselves was to test and validate a number of industrial demonstration 3D printing projects in different application fields. At the time of closure, we had received 30 applications, of which 10 were financially supported following an evaluation process. It's noteworthy to mention that these projects, or at least the SMEs that are active within these projects, are coming from 5 different member states, and the facility centers who are part of their implementation consortia, who are also registered on the 3DP PanEU platform, came from 10 different member states. So all in all, with these 10 projects, we had a nice geographic distribution and representation from organizations based in different countries. You'll be receiving more information on some of the projects that have been supported through 3DP PanEU. But just to give you some insight, some of the application fields included the agricultural, automotive, aerospace, manufacturing and construction sectors. And then finally, as mentioned, there were 3 key activities: the analysis and the reports on the EU 3D printing and additive manufacturing landscape being one of those 3 key deliverables from 3DP Pan-EU. This was an analysis which was conducted, and the drafting of the report was conducted by our project partner Idea Consult. They worked not only through the information and the data which we had gathered through the 3DP Pan-EU platform, but also looked at different studies and different reports which have been produced in the past to get a better insight into where we currently stand in a developing landscape of additive manufacturing within the EU, and also identify the current gaps and barriers which we can see. Also highlighting several technology trends within additive manufacturing. I'm not going to dive too deep into this right now because obviously we have a more in-depth presentation later on in the program at 12 o'clock by Idea Consult. But just to let you know that this was definitely one of the big components which we were working on within the 3DP Pan-EU project. So this was just a quick overview of the project, the key activities that we've been working on over the past 2 years. And the main, or at least a large part of today's event, will be to also communicate and to show you some of these results that we've been able to achieve. So having said that, I would like to move over into the next block, which we have prepared for you today, which is the first round of SME presentations. The way that this will be structured is we have half an hour for this block, 10 minutes. You'll be receiving 10-minute presentations on the projects, and then we will also have some time for Q&A, reflection, and discussion towards the end. Our first block today is focused on specialized solutions enabled by materials. And to present their projects, we have 2 speakers, Gaurav Das from Renotech, an SME based in Finland, and we have Luca Raimondi representing the MIND consortium. MIND is an organization based in Italy. Having said that, I would like to pass the floor and the microphone to Gaurav to start off this block and to share their presentation. So Gaurav, if you could please unmute your microphone, if you could turn on your camera. If you want, you can share your screen so you can click through the presentation and the slides at your own pace.
Okay. Thank you, Tim.
There you go. You should be able to share your screen.
Yes, just a second, I'm working on it. Can you see my screen now?
Yep.
Okay, just a second. All right, can you hear me properly?
Yes, perfect.
Okay, all right, all set to go. Good morning, everyone. My name is Gaurav Das. I'm the manager of technology and new business in the area of additive manufacturing and advanced materials for a Finnish SME called Renotech. We are focused in advanced materials technology and specialty construction printing. Today I'm going to talk about the project which we conducted under this 3D Pan program, which was named as 3D construction printing for marine and terrestrial application, and which was co-funded by the European Commission. So let's get started. One of the big problems we have seen in the construction industry is that 950 tons of waste are produced per minute in the European Commission, 950 tons. By the end of this presentation, Europe has produced 9,500 tons of waste. That's 9,500 tons. So it is clear from these numbers that there is high carbon footprint and wasteful practices specifically in the construction industry. Another big challenge which SMEs or specialty construction companies find is to create complex textures and objects without wasteful approaches. Example, creating complex textures requires, for instance, stone carving, which is a subtracting manufacturing process and a source of waste. Additional problem is always the cost. We have found that the cost of construction increases exponentially with increase in geometrical complexity. However, the cost for 3D printing more or less remains the same. Given these three challenge areas, we need some sort of solution. We believe part of the answer of the solution is construction 3D printing, but with smart materials. Compared to subtractive methods, you can produce items with minimal waste. For certain items, of course, the combination of smart geometry and smart materials gives you completely new products with new functionalities. So what do we mean by smart materials? Just to give you a brief idea, they are, for instance, self-healing materials, which can give, for instance, indefinite lifespan to materials. So what do these self-healing materials actually mean? So example, if there is a crack on a block or an item, if it's self-healing in nature, the crack gets filled up, as you can see in the picture. So that white color material, that is a crack been filled up. So this in theory can give indefinite lifespan based on the item and the application. Another example is this bioreceptive materials, which, for instance, can act as carbon sink and bring down the overall carbon footprint of the finished products and items. So what we have done under this framework in this project, first of all, I will just like to highlight that we create a lot of proprietary designs. So since they're proprietary, I cannot share them openly. However, for the sake of this presentation, I can share some things in terms of design and the final products. So the printer which was under consideration was a robotic arm one, and the final items were marine items which had complex geometry and specialized material. So these were bioreceptive, which means like the design which was made had ecological properties and bioreceptive properties, as well as the material had, let's say, advanced functionalities. Some of the use cases of this which you are aiming is artificial reefs and shore walls. So these are some of the pictures you can see. Of course, we have not produced them. They have been taken from the internet, but this is what we are aiming into, the marine applications, for instance. And in the future, we want to develop our terrestrial application, example, making theme park units. We have gotten very, very good designs and very creative ones. And let's say small office buildings, pillars and other things, but this is for the future. So the vision and the project traction. Our vision is to become a leader in specialty construction 3D printing in Europe with focus on smart building materials. As we are advanced material technology SME focused on construction, specialty construction, we believe this gives us a unique value proposition in this new era of Industry 4.0. To give you a brief idea how the project proceeded, so the 3D PAN program started in January, and by the end of May, we had created a new business case incorporating the previous slides as you have seen. And by that time, we had majority of the designs, and specifically the bioreceptor designs and other hybrid manufacturing items were already received. It was in May, and by the end of September, we reached TRL 8 for the marine items, so we can already get started. So our team, the key leadership people are, for instance, me, I'm the project manager and technical lead in this area. We have Mr. Bob Talling, who is the owner and the managing director. And we have Rika Danielsson, the lady is a production manager. And in total, our company has about 14 staff and we are growing. Now, our consortium members, we had 5 companies. 3 of them were funded by the European Commission directly and indirectly, as you can see, Renotec from Finland, XYZ Lab Portugal, Here, I must take the opportunity to mention that XYZ Lab Portugal did an extremely good job. We were extremely happy with them, and we were in fact quite surprised by the good quality service and products that we were received from them. And we have already signed agreements to continue our development work through other projects with these guys. Then we had a company, Vertico Netherlands. Additionally, we sought the help of other companies, one from another SME from Finland and another SME from Canada. So we had 4 countries and including 3 EU states, as you can see, Finland, Portugal, Netherlands, and we also had one from North America, Canada. To give you a time span about how we reached this TRL8, so the EU 3D PAN was a 9-month project, which we know now, but we have been already working under this developments in the prior 9 months. So all in all, you can consider that 9 plus 9, it was 18-month project, and the 3D PAN program came at a quite an opportune time. So to conclude and to keep things short, we have created some new business and path to create more, where 3D PAN funding was crucial. Green products with bioreceptive properties and low carbon footprint have been created. Upskilling of workers, new knowledge and ideas. This is extremely important for SMEs because construction industry is an extremely conservative industry. So upskilling of workers, bringing new technology, introducing digitalization is a hurdle on its own. But through this program, at least there have been some beneficiaries. In fact, this has helped us quite a bit, and we are planning to do more work in this regard. Creation of new value chain, which has industry-wide impact. As you could see in our presentation slides before, we are aiming for both marine and terrestrial application, and not all SMEs have all the competences. So we have been making consortiums and we have been developing new projects and so on. I would say that I am at the moment creating 2 new EU R&D projects, and all the viewers out there who is watching, I urge you to reach out to me for collaboration and other cooperation. Thank you very much. I'm Gaurav Das, the Technology Manager of Renotech. Okay, Tim, I think I made it in time, just in time.
Yep, perfect. Thank you very much. And once again, just a brief reminder to the audience, if there are any questions which you would like to ask to any of our speakers, feel free to use the chat functionality also, as I will be keeping an eye on that as we move through our event. Having said that, I would like to pass the microphone and the floor to our next speaker and our next presenter, who will be Luca Raimondi on behalf of the MIND Consortium. So Luca, if you could turn on your camera, turn on your microphone and share your screen, we'll be ready for your presentation.
Good morning, everybody. Let's try to share the screen. Hope you will be able to see.
Yep.
Okay, so good morning, everybody. My name is Luca Raimondi from the University of Bologna. I was involved in the project 3DP ISUS for the demonstration of multi-material component that is a suspension control arm for automotive industry. Co-partners in these activities, for which MIND is the SME, are the Orebro University and the Facility Center 3D Metal. So basically the background and the aim of the project was to manufacture an hybrid metal to composite joint to be integrated into the lower control arm of a suspension for a sport car. The background, the company, the OEM, actually produced this component in aluminium, but to improve the drivability of the car and in order to achieve a weight reduction of the unsprung masses, the carbon fiber reinforced plastic has been recognized as a good candidate for metal replacement. And according to a feasibility study performed by the OEM, this weight reduction can be achieved quite easily. Basically, this control arm is already produced and is already mounted, the version in carbon fiber, in several cars already manufactured. Basically, in both aluminium and CFRP control arm, the steel bushings are press-fitted into the seats that are the holes that are presented in the control arm. And this operation is crucial because the connection between bushings and the control arm is actually obtained by friction only. This for composite is quite tricky because this operation may induce fatigue wearing as well corrosion in the assembly. And in order to improve reliability and safety, advantages can be obtained by co-molding metal insert during the whole manufacturing process. This technology has been demonstrated within Unibo, and basically the idea is to use a lattice structure 3D printed insert and to co-mold it with SMC to obtain a strong, durable connection between the metallic and the SMC component. So basically, this was the background of the project. We have developed new design, new tools for design lattice structure and on real automotive metal inserts based on a parametric design approach. We, thanks to the joint collaboration with our partner, 3D Metal, that is another facility center involved in the project, and whose task was to print the metal insert, we were able to understand the major limitation of this technology with regards to the application of which this insert were designed to. Basically, by performing this joint development, we have achieved some result in qualification of the process and the defects that actually are the bottlenecks to a widespread diffusion of 3D printing technology in the automotive industry. And basically, we were able to embed these defects already in the design phase in order to achieve a strong resistance despite the presence of defects. We have performed some simulation of the infiltration process using commercial tools, and we have proven that our design is really interesting for the application and is feasible on the technological point of view. We have produced already the mold for producing the part, and is the one represented in the picture. And actually, we are going to perform the infiltration test in a climate chamber. Unfortunately, due to some issue in the supply chain, the pre-preg was received only yesterday. So basically, the project was not able to demonstrate fully the, let's say, the achievement up to now. However, we are confident to conclude everything in the next weeks. We are very confident of this because based on our experience and based on what we have already studied, we will be able to achieve a huge increment of the mechanical properties of the component by means of at least 10 times in strength and more of 80 times in energy absorption, as demonstrated by the picture on the left. And by means of the computer tomography that will be conducted in Örebro University, we will be able also to understand the major limitation of the 3D printing technology while used for manufacturing hybrid metal to composite joint, and also to understand which will be the failure mechanisms that will dominate the joint while loading. Therefore, this will be very interesting for scale up the technology and to surpass some, let's say, obstacles that actually exist in the automotive industry that are mainly based on some concerns on the 3D printing technology. So thank you very much for the attention. I've tried to be quite strict. If there are any comments, please feel free to ask.
Thank you very much, Luca. No questions in the chat thus far, but in any case, we have the next 10 minutes or so to have some Q&A time and to also look into several aspects related to your project. I would also like to ask Luca Tomesani from the University of Bologna to quickly join in this section to provide some expert input and perspectives. No questions in the chat so far, but I'll keep my eye out. In any case, I do have some questions for both. Firstly, to Gaurav. You mentioned that the components that you had printed were for marine applications. Obviously, when dealing with nature and bio systems, you're going to be facing and confronted with several material considerations. Could you perhaps give us some more insight into how complex the material considerations are for your project or for your application area?
Okay, Tim, thank you for the question. So I will say that the materials are unique to our project as well as in the construction industry. Firstly, 3D printing is novel in its own right. Secondly, the use of special bioreceptive designs and materials are unique. The possibility of overall low carbon footprint is also a positive highlight. Now, when it comes to more details about the materials, what is the composition and the process of manufacturing, I would be a little bit reserved in this regard. However, for the audience out there, I would say that this is based on, let's say, regular building materials, concrete and on, but we have modified it in some ways to make it bioreceptive. Yes.
Okay, very good. Thank you. And how do you treat the sustainability aspects of these new materials? There's obviously room to explore greener production methods and to explore greener products. How do you see this this trend or this new application area and possibility of additive manufacturing? How do you see that this will impact your business or at least the industry at large?
Okay, so I will break it into two questions. One is the sustainability and one is the business part so that I can answer it more clearly. First of all, the new materials and processes that have been researched have been done so keeping in mind the sustainability aspect. we as a company, Renotech, have extensive experience with circular economy. Example, for the past 10 years, we have been working with many large companies from pulp and paper, mining, etc. And we have been providing technical recipe solution to them to create, let's say, building materials out of ashes, slags, dregs, and so on. But so we have good experience and know-how from the sustainability aspects as well as circular economy perspective. In the future, we will perform trials with secondary raw materials for these 3D printing ones. We did not use secondary materials now because obviously 9 months is too short to do more things, but we have this in mind. In fact, we have launched a project under another EU SME program where we have one of our key partners, XYZ Lab, who was also a partner with us in this project, where we will be working is specifically using secondary raw materials and doing 3D printing, hybrid manufacturing. So yes, sustainability is a key pillar of our approach and also to the companies present in our ecosystem. Now, your second question, which you were about the business aspects. Is it right, Tim, how it has? Okay, let's go for it. Our effort of hybrid manufacturing has been successful. This has led us to reach TRL 8 for a few product lines, namely the marine ones. Our eco-marine product line is nearly ready, as you could see already from the slides. The possibility to decrease carbon footprint under this program, new business creation, that is, we have received invites to provide 3D products for marine applications, which was worth 500,000 euro in the past for a marine restoration project. This makes Renotech unique in Finland and in Scandinavia. So the entire combination of business, sustainability, and all that. That was my answer, Tim.
Perfect. Thank you very much. And if I could address my next questions to Luca Tomesani and Luca Raimondi. Obviously, we had two different application areas, one in the construction field, one in the automotive sector. Luca, which new types of possibilities and trends do you see within the automotive sector, which are made possible by printing and manufacturing components in different materials, but also looking at how different materials can be combined to create new products and components?
Yes, thank you, Tim. If you can hear me well, the idea of the demo case, hybrid manufacturing, hybrid components, is about the need that industry has to put together different materials, and especially in there is a strong need to, as you know, to do lightweight materials and lightweight solution. So we have to combine composite materials to metals, and as far as you can do it, you can very much develop lightweight solution. So in our demo case, we have developed this functionality to create a very strong and deep interfaces between composite materials and 3D structures. But of course, as you are developing this idea, this concept, you have to create a lattice structure that have to be very sound and strong. At the same time, you have to understand how to infiltrate these lattice structures by a composite. And of course, the composite change a lot because you have different materials, different application and areas, and so any new application needs a further development of the idea by developing new structures, new lattice structures, and new composite, and also, of course, thinking at the recycling issues and so on. So it is a very vast sector of application, and there is a tremendous possibility to develop lightweight components in the future, as the automotive, and not only the automotive sector, is really asking for these solutions.
Thank you very much. And you mentioned in your answer the industry need to look at the development of new components and new products. Within this specific case, could you give us some general insight into how the interaction, or at least how the collaboration, what it looks like between yourself as a university and a facility center and a large OEM, or for that matter, an SME who has this need?
We have at least 3 themes involved in this technology. The first is at high level from the design of the interface, because any different application has some specific loads that must be withstand. And so there is an input from the design of the OEM. We need this kind of load, we need this kind of energy that can be absorbed. Starting from this, we can design the interface, so developing the geometry, the particular geometry of the lattice structure, the density, how thick it will be, and very specific geometrical aspects. Then you go into the details of manufacturing of the 3DP, of course, and you have to deal very carefully with this, as you know, that the load is going to be applied on the 3DP structure. So it must be very, 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 very sound and full density, of course. And the third aspect is about the composite, because you have the composite with its own characteristics that must flow inside of the 3DP. So what we have done in the past years here on the University of Bologna is to develop together all these 3 aspects. And so what we can do now, and this is of course why these aspects must be combined together. We can do the design of the joint, the manufacturing of the 3DP, and then the infiltration by the composite. So it is it may seem complex, but as far as we proceed in this kind of idea, we can give a specific part of this job to industrial providers. So, and this is what we have done in this particular project. So we could give some part of this job to industrial providers for the 3DP manufacturing, for example.
Okay, thank you. Thank you very much for your contributions. I see that there are no questions in the chat yet. Once again, if you do have a question, feel free to pose it through the chat functionality. But yeah, once again, a big thank you to Luca, to Gaurav, and to the other Luca as well, of course, for your contributions and for sharing the information. Right now we have a short break scheduled, which will last around 10 minutes. What I will do, however, because to also provide you with some extra information about some of the projects that we have funded through 3DP PanEU, we've prepared some informational videos, which I will put on screen now. I will allow them to run. They should take around 4 minutes altogether, and then we'll still have some time remaining for a regular break. In any case, we will reconvene and we will continue with our program at 11. So enjoy the videos and see you in about 10 minutes time. Thank you. Okay, I hope you've all had a nice little break, had a chance to maybe get something to drink. Also hope that you enjoyed the videos which we've prepared and which were shown. Just as for your information, we're going to be preparing, or we are preparing, videos for each of the 10 projects which have been supported by 3DP Pan EU, and these will be posted on our project website once ready. So keep an eye out for the remaining videos. But having said that, I would like to continue with the program, moving into the next segment which we have prepared, which is another round of SME project presentations, this time focusing on capitalizing on very short development cycles. To produce or to present their projects, we have Ms. Berta Gonzalvo from Moses Productos, a Spanish SME. We have Mr. Tommaso Tirelli from iDrill, based in Italy. And as we had last time, we have Mr. Jose Antonio Diez from Fundación ITIP to join us during the final 10 minutes of this segment for the Q&A. So having said that, I would like to pass the floor to Ms. Berta Gonzalvo for her presentation on the Agri AM project. So Berta, if you could unmute your microphone, share or turn on your camera and share your screen, then we can get started with your project presentation.
Hello, morning team. Hello, Mr. Marsa. Hello, 3D Print PEM EU project partners and audience in general. Thank you for the opportunity to share with you our experience in this project. Okay, Moses is a Spanish SME that was founded in 2018, and it's expert company focused in transformation of fossil-based materials, bio-based materials, and biodegradable materials, using mainly extrusion compounding techniques and plastics molding processes. Moses' aim is to develop the most appropriate material for each specific product to our customers that meets their requirements and their needs, targeting mainly different sectors as agricultural sector. That is the case of our case in this context, packaging and medical sectors as well. But we are open to all kind of industries. Mainly these are those that we are mainly now running projects and products to the market. Now we are 10 people working, 10 employees, and when we submit a proposal for this 3DP PAM call, we were only 3 people. It's a spin-off of a technology center with more than 25 years experience in plastic sector. Despite that our company, Moses, is quite new, we have just invested in state-of-the-art facilities, machinery, human capital, and of course, we are focusing in how to adapt our talent to the customer needs. Moses has relevant projects running to Horizon 2020 project and some products with biomaterials and advanced materials in the market. Then our company is mainly focused in an eco-innovative perspective, and in all the projects that we are designing and offering to our customers, we try to reduce the impact in the environment, not only in the processes as well as in the product concept. Then we try to combine these 2 values. And of course, you have our website there to check our activities and of course my data to connect with me. Okay, we go directly now to the issue of our case. This is a problem that our team saw some years ago. You can see here how our regional government in Aragon fund a project in order to analyze the risk of fires caused by agricultural machines during the harvesting times. Okay. We can see, for instance, here a video that perfectly shows us the impact of this kind of accidents in the field. We have here as well some reports coming from the University of Zaragoza, University of Navarra, and a private foundation, MAFRE, that was our main point in order to try to conceive the concept of the product that we finally develop. In Spain only, we have 28,000 combined harvesters, and mainly I'm focused in 3 regions: our region, Aragon, Castilla y León, and Castilla-La Mancha. And the main origins of fire are caused by cutting bars, with 31%. The ignition temperatures of the residues accumulated in the machine in a very high range, 25 to 340, depending on the size and the thickness. And we notice as well very high temperatures in the motor zone, mainly in three tones, and mainly in the cutter bar, like this piece. We have very high temperatures, mainly of 400 grades during operations of 10-15 minutes. More studies about forest fires in Spain during these years. And finally, we definitely find a way to have a proof of concept in order to check if we could print directly a part, okay, coming from the file to the product using 3D printers, in order to check that is enough from the mechanical performance that we need, but we haven't a successful result, but we learn a lot about the way to produce a new concept of plastic product instead of metal during the project. Then, basically, EGRIE-M consists in using metal additive manufacturing technologies to manufacture injection molds for producing plastic parts for conventional process like is injection molding for this agricultural machinery sector. Moses needs to respond to this high impact market need with the manufacturing of a small batches in order to check if the performance of these high customized thermoplastic products connect with the needs of the project. Conventional technologies are not feasible nor profitable in cost or time. Then EGRIE-M proposed the rapid manufacturing of medium and large metal molds using direct energy deposition, DEC arc. Of course, together with our facility centers, in this case, we work with ITIP and TECOS and Univo, TECOS in Slovenia and Univo in Bologna. And we developed these 8 activities from the product redesign, mold design for this AM manufacturing technology. We generate the trajectories and printing program for this case. The 4th activity was to design the different elements of the tool in order to be manufactured for this hybrid manufacturing, combining DEC arc and subtractive technology. Finally, we prepare the tool, adjust it, finishing, and goes directly to the injection tails in order to carry out the production as small batches with this thermoplastic material selected with very high amount of fiber in order to be aligned with the mechanical needs. Finally, of course, we test these samples, these tools with mechanical test and with the different materials that we carry out these batches. And we prepare as well a live analysis, mainly strength, robustness, and durability with 100 cycles. Finally, the real proof that is a very good solution, we prepare parts in real operation scenario in cereal harvesting processes in different sites, okay? And finally, we reach a plan for the certification of this new product, and we are now connecting to the market and to be ready this product for the next year. In this video, we can show the production of this part of the tool to prepare this tool to produce the injection of the parts. Here you can see as well a sample of one of the parts of the tool. This was the first trial that we have. Okay, and here you can see some pictures of the male and female part, okay, the both sides of the tool, designed and manufactured by one technology. Finally, you can see here as well the part of, we put the tool in the injection mold machine. As you can see, all the connections for the cooling process of the part inside the tool and the machine. And we get it 1,500 injection cycles performed and no damage in the tool, and of course in the parts as well. Okay, we obtain it in different materials. You can see here some blue and some red like this, okay, because we tested different formulations, different solutions to check the mechanical properties later. You can see here and in this place. As you can see, the mechanical efforts that we get in this manufacturing processes, in this process of harvesting is. You can see here some pictures of the parts that we implement in these machines. As you can see, only we replace some parts, mechanic parts, metal parts, not all the line. Okay, you can see in the middle a line, a completely line, but in other cases we prove as well the combination between the mechanic ones and the conventional ones and the new parts that we prepare in this project. Finally, I would like to thank, of course, this project, the 3DP PanU support that was essential to develop these parts, this solution for a real need. Very fruitful cooperations between AITIB, TECOS, and UNIVO, thanks, of course, to all the teams in these facility centers to develop this solution, this new process, this new product. New knowledge creation, very good point as well, and of course, new research and development opportunities for the near future, and of course, to optimize this product in the market. Of course, a list of our testers, the people that test these parts in a real scenario. Thank you very much.
Thank you, Berta, for your presentation. Very interesting project and content which you've shared. Moving over to the second of the presentations within this block, I would like to pass the floor to Mr. Tommaso Tirelli from Hydro for his presentation on their SME project. So, Tommaso, please, the floor is yours.
Thank you. So, sorry, maybe I have to make a better screen share. So, do you see my screen?
Yep, perfect.
Perfect. So, my name is Tommaso Tirelli, and I'm the CEO of Hydro, which is a company with a specific skill in oil hydraulics and additive manufacturing. Before going to the detail of our project, which is about the use of additive manufacturing in heat exchangers, I will give you a short introduction about the company. So we're a small company based in northern Italy, 15 people. A few weeks ago, we've been acquired by Desktop Metal, just I would say at the end of the 3D project. Our core business is the engineering and manufacturing of fluid-powered devices, including valves, hydraulic manifolds, and heat exchangers. And in general, we can say that we have a specific expertise with the devices that has fluids under pressure to be designed and manufactured by additive manufacturing. We have some additive manufacturing in-house capabilities, but for this project, we also relied on an external supplier because we wanted to experiment another material with respect to the ones we have in-house. And we are EN 9100 certified company, so we have the aeronautical certification, and this project in particular was also targeted to one of our potential customer in this frame, so a helicopter manufacturer. So we defined a sort of roadmap for the additive manufacturing. As mentioned, we're mainly focused on the use of additive manufacturing in fluid power, but also in oil and gas and aerospace. The idea behind is that we can use the advantages of additive manufacturing in order to introduce innovation to very consolidated and standard products like the valve that you see here in this picture. Through additive manufacturing, we prove that it's possible to reduce weight, increase the performance, and have a series of advantages, of course, in general, for very niche applications, so the application where there is a high added value and a customer that is keen to pay for the extra costs which are normally related to additive manufacturing processes. For example, this is another case of application for an hydraulic manifold that has been completely redesigned starting from an hydraulic scheme and has been adopted on a racing boat. There was crucial the weight saving, so we proved that by using aluminum 3D printed, the performance of the manifold was very efficient and the save of weight was important. Of course, the save of weight goes also with the reduction of CO2 emission, which is, I would say, a very fashionable theme recently, but we proved by a study that it is possible really to reduce the CO2 footprint through additive manufacturing, because on one hand we reduce weight and on the other we reduce the number of components. And we can also think about the digital inventory, so reducing the physical stocks with the files. And this is something that is becoming more and more actual. Concerning the heat exchangers, the idea behind was to switch from a traditional manufacturing technique, normally made of plate, fin, or tubes, into a new structure, a monolithic structure made of metal powder, melted metal powder, and of course by using and exploiting the advantages that additive manufacturing can offer in terms of complexity. So those are some examples, but maybe I can go directly to our project. So we used the so-called gyroid surfaces. So those are surfaces that are so-called minimal surfaces, the ones that optimize for a given volume the surface, so they can provide a better heat exchange. This is something that, of course, is only feasible by 3D printing and not by traditional manufacturing. There are libraries of this kind of surfaces, but what we wanted to do in this project was to introduce a variable porosity into our device, meaning that we wanted to change the frequency of the gyroid surface in order to have a better performance on the device. So the target was to have higher heat exchangers and at the same time by keeping low the pressure drops. So we started by using, let's say, the facility center Optimad engineering that helped us in modeling the heat exchanger. So starting from starting version where the gyroids are, let's say, fixed in terms of frequency, it has been possible to model and to simulate the behavior on a thermal and fluid dynamics point of view. Then the second step was to change the frequency of the gyroid surface in certain zones in order to have a controlled flow. So in this picture you see that there is cooling water and hot oil. So you can understand that the idea was to cool the hot oil with water. And indeed, we proved that not only was possible to model this this pattern, but we also proved from a simulation point of view that we could have a better behavior in terms of heat exchange. And this design activity was quite sophisticated one. So the facility center relied on high-performing computers and used specific tools for the design. And this was a sort of first step for us in order to introduce the possibility to change the frequency of the gyroid on a controlled way in order to obtain what we call a controlled porosity device. The second part of the project was to prove the printability of the solution, because of course you can design everything, but at the end something has to be realized in concrete. So we printed some samples, some section of the device. One was done in copper alloy and another one was made in aluminum. So there in those pictures you see that there is indeed this pattern which changes according to the zone where we wanted to address the flows. The other very important topic with respect to this project was the possibility to depowder the device, because you can understand that on a laser powder bed fusion process, the metal powder remains trapped into the voids and has to be removed. So we tested finishing, so an electrochemical treatment for the powdering, which can be used both for reducing the surface roughness, but was not our intention here. Here we wanted to use this technology to ensure the cleaning from the residual powder of the process inside the device. And the first attempt has been successful, and we also measured that through computer tomography. This project, which is something for us very important because it's a sort of first step that has been, enabled by the participation to 3D PAN, is something that we wanted to push and to go in further details. It's candidated to the Poor Mundus Challenge. So in case some of you will be in Frankfurt for Formnext, please go to the stand of Poor Mundus and vote for our project. And I just want to conclude with a video that we prepared, of course, for this challenge. We renamed the project into Tukanbik. Tukanbik is an example of topological optimization by nature. Its structure is very lightweight, but at the same time is stiff, thanks to a controlled and variable porosity. Moreover, it integrates multiple functions, including a controllable vascular heat exchanger. Our project is based on metal additive manufacturing. Thanks to this technology, we can produce innovative surfaces with improved performance for heat exchanger. Our approach is a multidisciplinary topological optimization with advanced simulation tools, machine learning, and high-performance computer deployments. That's it. Thank you.
Thank you very much, Tommaso. And of course, good luck during the upcoming Formnext event, which is taking place very soon. Thank you for your presentation and the information which you've provided. I would like to ask Berta and Mr. José Antonio Diest from Fundación ITIP to join in these last couple of minutes in which we can have a bit of a discussion or a Q&A on the topic. Thank you for joining. First question which I have aimed at Berta. Your project obviously deals with the agricultural sector, in which a large part of the harvesting and the growing of crops is dependent on the seasons. How has the introduction of additive manufacturing impacted what companies can do within a single harvesting season, or at least how has the reduction of development cycles and the ability to produce new components faster, how has that created added value or benefit to companies working within the agricultural sector?
Thank you, Tim. Thank you for the question. Very interesting, of course. It's part of the, let me say, the reflection of the case that we have just developed with this project with EGRI-M. It's true that additive manufacturing has been demonstrated to allow the prototype fabrication in a very short time and reducing, of course, the resources, totally aligned with the objectives of Moses Productos, our company. And as you can see in my presentation, the first step was to go directly to a part, okay, printing by FDM. However, we didn't be able to reach the mechanical properties that we need for the performance of the applications. Then we go directly to the second option that was, as you can see, the preparation of this additive manufacturing tool, using, of course, the knowledge of these three facility centers, knowledge and infrastructures. During the process, of course, we established a re-engineering cycle that is part of conventional life of a process, but it's true that for this kind of agricultural sector is very interesting. It's a need to test the product during a very short period of time, that is the harvest session, and in Spain it's around 6-8 weeks. Then we haven't a lot of time to re-engineering the process and the product and starting with a new solution. For conventional fabrications, of course, we didn't have the time to do that. However, with this kind of concept, with metallic 3D printing, was possible to demonstrate that it's feasible to prepare tools and molds in less than 4 weeks, leaving room for test during the campaign, and then finally have this solution. Then it's a clear example that in this sector is possible, is totally aligned, but of course we learn the lesson that we can transfer these solutions to other industries and sectors as well. Thank you.
Perfect. Thank you very much. Also, a quick question to Tommaso. Within your project, you highlighted the fact that obviously there were the different stages in which work was done, from the designing to the eventual printing, the printing in different materials. The flexibility provided by additive manufacturing and the ability to produce different prototypes in rapid succession. How would you say that this benefit, or at least this characteristic of additive manufacturing, how has it impacted the project or your company in a broader sense?
Okay, so of course, one can use additive manufacturing for rapid prototyping. In our case, additive manufacturing is really the technology that we will use for the production of those kind of devices. Of course, we are, I would say, for the moment, at a quite early stage, Of course, our aim is to industrialize this solution, especially from a design point of view. So I would say that the rapidity itself of the process in terms of design and realization is crucial for this project.
Perfect, thank you very much. And finally, a question to Mr. José Antonio Díaz from Fundación ITIP. As a facility center, obviously you collaborate a lot with businesses, with SMEs. To what extent would you say that the ability to manufacture components quickly and to have rapid prototyping, to what extent do you think that this is one of the key success factors towards the adoption of additive manufacturing in a broader sense?
Hello, thank you very much, Tim, for the question. So I'm totally sure that this is a must. We have been watching two presentations. The one I know is a final product that needs to reach the market in a very short time, that needs to be accelerated, that time to market should be reduced, and even in most cases, the tooling manufacturing should be reduced in time in order to reach the market as soon as possible. So trying to reduce this time for manufacturing is essential for us as facility centers in order to provide these SMEs the possibility to grow and to go to the market and to be competitive. So additive manufacturing is a must. It should be and must be accelerated from now because from the facility center, research center, we have been making a lot of advances in small TRLs, but now is the time to go to the final users of the technology and to reach directly the market, as the examples that you have been seeing in the presentations of Hydro and Agri.
Very good, thank you. We're a bit over time, but that's perfectly fine. Big thank you to Mr. Tommaso Tirelli, Ms. Berta Gonzalvo, and Mr. José Antonio Díaz, who will be joining us as well in the next section. But thank you for your presentations and for sharing your information. As mentioned, we are moving towards the next block of the program, which is a broader discussion with various experts from the additive manufacturing field to discuss the access of specialized expertise and infrastructure through interregional collaboration. So joining us for this discussion, we have Mr. José Antonio Díaz, who you've just seen. We have Mr. Luca Tomesani from the University of Bologna, who is going to be rejoining. We have Mr. Christian Wogerer from Profactor, and supporting we have Jean-François Romainville from Idea Consult, one of the project partners of 3DP PanEU. So if our speakers could please unmute their microphones and share their cameras, that would be perfect. Just to kickstart the discussion and as a general introduction, our speakers have some slides to briefly introduce themselves and to share a bit more information about their organization and the different services which they provide. So I suggest we get started with that. If I could just go down the list as they're currently on the slide, I would like to start by asking Luca, if you could briefly introduce yourself, the University of Bologna as a facility center for the audience.
Yeah. Thank you, Tim. I'm Luca Tomesani from, as you said, the University of Bologna. I belong to the Department of Industrial Engineering. We are pretty numerous, and inside the department we have different teams. In particular, we have a team developing additive manufacturing technology. Then we have a composite, a group developing composites, and also a group focused on design of mechanical components. And in this particular field, additive manufacturing allows to integrate different technologies, and this is why we used all these three kind of experts.
Okay, perfect. Thank you very much. Moving to our next speaker, Mr. Jose Antonio Diest. If you could briefly introduce yourself, your organization, and if you have slides, please feel free to put them on the screen.
Yes, thank you very much, Tim. So I have a presentation that I wanted to share with you in order to show us as facility center. So I'm representing IT Technology Center. We are a technology center in Spain, in Zaragoza. And here in the slide, some figures and some numbers regarding the entity. So the main thing that we are working 140 people in the facility center. We are making a lot of European research projects. In this case, we have been making 52 European projects, and we have been coordinating 15 of them in Edge 2020. And the main thing in this case is that we are very close to the industry, to the SMEs. We have more than 200 industrial partners per year, and 65% of these companies are SMEs. So we are proud to be a facility center quite close to the industry and to the final needs. So these are our main research lines. So we have before advanced materials, efficient manufacturing, circular bioeconomy, and digitization. That all of them has to be integrated and joined in order to make developments and services in additive manufacturing. So regarding our expertise, our services, I took this picture directly from 3D PanU matching tool that we consider that is very interesting for us to promote our expertise and to make this link with the requirements and the needs of the industry. So this is directly taken from the matching tool developed for the project. So thank you very much. It's very, very nice and very useful for us. And you can see that we have quite a large equipment in additive manufacturing. We have our lab with different machines. We are working with different materials, metal ones, polymer ones. We have very large industrial 3D printers. We can provide quite a lot of services for our SMEs. And I wanted to align a little bit with one of the presentations that you have seen, is the Moses one. And apart from the services that we can provide, we are working in research also, and we have quite a large achievements during last year. So now we are working in order to provide the possibility to the industry to print large parts. That is one of our main intentions. So we can print polymers and metals in large formats, and this is the advances that Moses for the Agrian project. We have a large experience in 3D printing. We started in 2000, and you can see in the upper part of the slide one prototype we printed in 2008. It was an SLS prototype, very, very nice, but we wanted to go beyond. And now we are working in order to provide the possibility of print large metal parts. So I wanted to show you this kind of video. And it's the same prototype, but this time made by the ARC one process. And we have been working in printing very large formats. We are able to print 20 meters long parts and providing a large amount of material, in this case 5 kilograms per hour. That is one of the things that industry requires in order to make 3D printing profitable for them. This research we have transferred to Agrian project, and you have seen this video that was shown by Berta. Is the same technology. the same approach, but this time made for them in order to demonstrate large scale manufacturing for injection mold. It's a large impact because it can be used in several applications, in several industries, and it's not only for building the tools, but also for the final process. In this case, the main things is that the raw material consumption is reduced. We have spent 45% of the material if it was done in the conventional way. We are reducing the inertial, the thermal inertia that is very important for some application. We have been watching hydro and Moses. In both cases, the thermal performance of the part is important, and we are profiting from 3D printing for this application. For the industry, important to reduce this type of market, also for printing the tools, increasing the benefits for the SMEs, and one very important thing is to reduce the waste, to reduce the amount of material, to reduce the energy consumed for the products. So thank you very much.
Thank you. And then finally, we have joining as expert speaker, Mr. Christian Woberer from Profactor. If you could please introduce yourself, your organization. If you have slides, feel free to share your screen.
Okay, thank you, Tim. I feel free. I hope I can do it, the sharing. Yes, it works. That's the wrong. So I think now you see my presentation, my slides.
Yes. Correct. Yeah.
Yes, now in full modus. Okay, try to keep it short, but I can promise it. My name is Christian Woberer. I'm coming from the company Profactor. We are a non-university research institute based in Upper Austria, Steyr, and in Vienna. What's our profile? We have two fields of research. I marked the red, which is important for our project, for our 3D band project. This is the additive micro and nano manufacturing department with micro and nanostructures and functional surfaces, mainly based on 3D inkjet printing with various materials. Some facts and figures. Sorry, I was too fast. We were founded in 1995. We have approximately 75 employees and the turnover of several million euros, where 4 million euros are directly coming from the industry. Yes, and 2 locations in Steyr and in Vienna. So, no pause. Okay, these are some solutions we have. These are functional surfaces. Rapid prototyping based on 3D printing, micro and nanostructures based on inkjet printing and also 3D printing, coatings, measurements, and a lot of areas. What are our main fields are the robot-assisted inkjet printing. Here you see a demo from a sport shoe. We are not focusing on decorative printing, more or less on functional 3D printing, then functional elements on curved surfaces, textiles, and digital paint printing. Our main focus here. You see a picture of the robot-assisted printing, and this is a technology we are still bringing in the industry, mainly on textiles and so on. What we have done in the last years is more or less going from 3D printing of flat surfaces to curved surfaces, first smooth curved surfaces, and then more to extremely curved surfaces with the with a robotic-based solution where the inkjet head and also the curing system is mounted on the robot. We are printing with various materials, with industrial partners, with electric conductive inks and so on, and therefore we have a lot of solutions. What we can provide as infrastructure, I think, Tim, you wanted also an idea of this. We have a lot of open labs, cognitive factory, open mobile lab, also 3D printing facilities are available. A cognitive robotic and factory hub lab where the inkjet-based robotic infrastructure is available. And what I want to present at least is, if we are talking about infrastructure, in Austria we have the Austrian 3D printing platform, the AM Austria, and I briefly want to show you their homepage. If here you can find in a consortium of almost 60 partners and access to even all possible 3D printing facilities you need. And what I want to mention is Austria has the highest density of 3D printer manufacturing in the world. Maybe that is based on this, that we are so small. So, okay, good. And if anybody is really interested in this platform, which provides really a lot of benefits additional to Profactor, I think you will get the slides afterwards from Tim. They have all informations. Okay, that was
Perfect.
it. I give you back the screen.
Yep, perfect. Okay. Thank you very much. And finally, I would like to offer Jean-François Romainville, project partner, the opportunity to briefly introduce himself. He has a presentation coming up later, so you'll hear more from him at length, but we're including Jean-François in the discussion now to bridge the gap between the conversation we're having with our experts as well as the report later. So Jean-François, if you could briefly introduce yourself to the audience.
Thanks, Tim. So I'm Jean-François Romainville from IDEA Consult, expert in industrial and innovation policy. So indeed, as Tim mentioned, it's at 12, if I'm not mistaken, we'll have a presentation on the analysis we have done in the context of the 3DP Pan-EU project, focusing on the market for AM demonstration services. Based already on what our experts disclosed during this session, it's already quite clear that cross-regional cooperation is key, because they have such specialized expertise. The three experts we were able to learn more about right now, they have very specialized expertise that you cannot find in every regions. So it's very important that such specialized expertise is made available across all regions through different tools that we will explain later. Also very important that we are addressing, and this is some things they are doing, key emerging trends. So really innovation, let's say, areas that will be key in the future, that will be more and more demanded by SMEs. And I think it's good that we had these three examples with the lighter components aspects of Unibo, the need for multi-materials components, which is obviously a key area for the future. Same for Profactor and the expertise on structural integrated electronics. That's for sure a promising area as well that will be more and more demanded by SMEs. And the aspect, for example, of large parts, rapid prototyping for large parts as well, that was put forward by ATIP. So very nice illustrative examples of the importance of cross-regional collaboration in my view. Also, maybe a final word on the fact that facility centers do provide a very comprehensive set of services for SMEs, and they should be seen not really on a linear sequence, but really they are able to make this integration between research and these industrial needs. So it's not really a step, it's really an integrator between both. And they do offer services that enable to test before invest, which is key in additive manufacturing, because going additive for SMEs can be quite costly. So you really need to offer to SMEs this opportunity to co-develop, test and demonstrate solutions. So the role of facility centers in the AM value chain is really crucial to unlock private investment, to facilitate twin transitions, for example. So important role to be highlighted a bit later as well at 12 o'clock.
Perfect, thank you very much. Just another brief reminder that, of course, this is a discussion, so if there are any points or questions from the audience which you would like to raise or bring forward, please feel free to do so. I'll keep my eye out on that. But in any case, I have several questions based on the content that we've had today, and also complementing what was mentioned by Jean-Francois. Of course, there is indeed this need to provide access to high quality services and infrastructure within the field of additive manufacturing and 3D printing. But just out of curiosity from your perspective as well, are there any types of or specific types of projects which fit this need for interregional collaboration better than others, would you say? In other words, to what degree does the availability of very specialized and unique and differentiated services create the need for interregional collaboration? If I could start perhaps with Luca on your views on this point.
Well, I must say that there is, of course, a need to be faster in developing new solutions, especially in innovation field, and so there is a real strong need to go where you have this knowledge, where the knowledge is normally at the beginning is very far from you, and so there is a need starting from an SMEs or from an OEM, and you have to spread the idea all around and to find where this knowledge is in order to have it. And one other point is about the need of having industrial providers, because you don't need just need to find RTOs, but you need an industry with complex equipment and very costly sometimes. I'm thinking, of course, as composites. If you want to bring together metal and composite, you need big presses, and so you have also industrial providers to be part of this network. It's very important.
Thank you very much. Clear answer. I don't know if there are any other points to be added from either Christian or Jose Antonio on this point.
Yeah, may I jump in? So,
yeah.
Sorry. Yeah, I'm fully with you. What I want to mention is the access to infrastructure or critical infrastructure in the case of 3D printing. It's not enough to buy a printer. It's not enough to build up a printer. What you need is people who are able to work with these printers, to work with these machines, and people which are able to integrate this into the process chain of the industry. And there, now I'm coming to the example of Austria. There are a lot of printers and so on available, but if you concentrate your forces to really center, because you can buy a lot of machines, but you cannot educate a lot of people in a adequate time which can work with this, and so the transfer is limited. That is for RTOs, and that is also for the industry. That is for both. Okay, that is what I want to mention, and concentrating the forces would be very helpful.
Yeah, Yeah.
So maybe the European Digital Innovation Hubs will be helpful for this. Maybe we will see. Okay.
Yeah. Yeah. Thank you. I think that's a clear message. Jose Antonio, anything from your side?
Yeah. Thank you very much. I agree with Christian and Luca, and I think that it's very important, the collaboration, cross-border collaboration between us. They are very know-how experts in their research fields. They have infrastructures that we don't have. So at the end of the day, we have a limited knowledge, and sharing and collaborating within this kind of nets of even facility centers is a need in order to go on and to go to the market. And my point is that it's quite important to start to make the technology transfer to the industry. It's difficult because we have to promote the know-how, the skills, and even the infrastructure. But at the end of the day, if we want 3D printing to the industry, we have to reach this technology transfer and let industry go by their own.
Yeah, thank you. As mentioned, I think a very clear message. One more question that I would like to ask is all three of your organizations, so Fundación ITIP, Profactor, and the University of Bologna, were all involved in the SME projects, which were financially supported by 3DP Pan-EU. Within these projects, we obviously had the SME and the lead collaborating with different facility centers in different locations in Europe. From your perspective as a facility center, have these projects, or do these type of projects also bring added benefits or added value to you as a facility center in the continuous development of your working areas or things like this? Or would you say that the key added value at this point is really focused on facilitating this knowledge transfer and promoting additive manufacturing as a technology? If I could start once again with Luca, perhaps.
Thank you, Tim. Of course, yes. The most added value we have is knowing other facility centers, other companies throughout Europe. Especially in this period, we are planning the cooperation with other universities and centers for the Horizon 2020. So it is of utmost importance now to know the many more people we can, and to understand where the knowledge is in order to build a very sound and robust cooperation and network. This is really the most important value, much more than the specific work we did for the SMEs. Is to find and to build a network of people working together.
Thank you. Any additional points from?
I'm in line with Luca's statements. It's very important for us to have this network for cooperations, not only for these projects, but for a broader perspective. But participating in these fast cycles projects for us is important in order to be on the track. We are collaborating with industry. They know what they need. They know what is going to be in the market. And for us, it's very important to have that perspective, because they can reorient our researches, our research lines, in order to be totally aligned with the market. Because at the end of the day, we are making research for manufacturing, and the manufacturing has to have a market, the end users, and we have to orient to this market somehow.
Yeah, it's everything said. So I don't know what I want to mention again. For Profactor, it was a starting point of a good collaboration with the second provider, and it was a kick for us that we went deeper in detail of the provided technology. It was a starting point, and the money we get was a nice add-on. So, okay, good. So not more to say. Okay.
No, that's perfectly fine. And in any case, in your presentation with the example that you presented on the Austrian additive manufacturing platform, I think that further highlights the need to bridge different gaps between SMEs, facility centers, between facility centers and other facility centers, and the different actors that we have within the additive manufacturing field.
May I add something to this platform? I think one of the success factor of this platform was that it was industrial driven. There were a lot of research institutes and universities integrated, but really the director of this platform and the leading positions are by the industry. But by an industry which understands that they need research, that they need the development, and that the 3D printing is not a technology which is still finished developed. So that was, but I don't have any idea how you can initiate this as RTO. So that must come from the industries. This is for me the success factor, and I know a lot of platforms which are driven by the researchers. They are also good. But yeah, okay.
All right, thank you very much. Having said that, I think with 2 minutes past 12, we're ready to move to the next block. So I would like to give a big thank you to Christian Wogerer from Profactor, Mr. Jose Antonio Diest from Fundación ITIP, and Mr. Luca Tomesani from the University of Bologna. Our next speaker, as mentioned, is Jean-François Romainville from IDEA Consult. So I would like to pass the floor to Jean-François to guide us through your presentation.
Wim, can you confirm you see the slides in presenter mode? Okay. So thanks a lot. I will not reintroduce myself. I will start directly. So now short presentation on the key results of the study focusing on the market for AM demonstration services and equipment. The structure of today's presentation is rather straightforward. We will start with an analysis of the demand side. So demand side in that context means the needs of SMEs, companies in terms of co-developing, testing and demonstrating AM-based solutions. Then an analysis of the supply side, so the equipment and expertise in the field of demonstration activities that are available on the market. So basically from the facility center side. Then we will conclude with some gaps identified and some possible recommendations associated to these gaps. I will be quite brief today. We have a lot of materials. I will not be able to go into the details of all results achieved, but please be aware that we will circulate the slides, and on the 3DP panel website you will have an executive summary and a final report disclosing all the results in details. Also, please do not hesitate to contact me by emails or of course today in the chat if you have some questions or remarks. The approach of the study very straightforward as well. As you understood, we are focusing in these projects in particular on activities at TRL 5, 6, 7, so demonstration activities. But in order to really grasp what will be the evolutions in these areas, it's important to have a view on the overall AM market. So in the study, we started with an analysis of the AM landscape as a whole, including fully deployed industrial activities, but also research at a bit lower TRL. Then we dived into really the core focal point, which was the market for demonstration services and equipment. And for that, we mainly used the data sets we were able to build in the context of the 3DP PANEU project based on data from the matchmaking tool. I will get back to that later. Finally, we have some key takeaways and recommendations in the end. So it's a mix of desk research, data analysis, and also experts consultation. We consulted some experts in view of validating the results. So main source for the analysis is the 3DP PANEU dataset. So this is a dataset that was built based on the matching tool we developed. And how we have built that dataset is very simple. We asked facility centers to register to make visible their expertise and equipment. And so we collected a lot of data on the supply side. So as Tim mentioned it, we had more than 300 facility centers registered, more than 1,000 pieces of equipment of AM printers listed and described in full details, like materials that were able to be printed, size of the parts, the application areas often targeted, and so on. Same for the services, what type of testing, for what type of parts again, and so on. And on the demand side, we had more than 3,000 searches in a few months. So we were able to also analyze these searches made by SMEs. We will know more about this, but it's important to point out that this description of the dataset is only a picture of a moment. Now we have upgraded that matchmaking tool to make it more effective. It will be also open to other actors in the AM value chain, so not only facility centers and SMEs, and it will be made also sustainable, including post-project execution. So that picture of the moment is aimed to be outdated, and we hope for much more data being available and visible to the overall AM value chain. But Wim de Kinderen will discuss this during the next presentation. So let's start now with some key results associated to the demand side. Starting with very generic evolutions worldwide and in Europe related to the market for AM solutions. As you can see, the total market value is expected to be multiplied by 10 in the period 2019-2029 to approach 16 billion in 2029. Number of actors also experienced high growth over the last years. And there it's important to mention that Europe has a strong position, but obviously with very high competition from other actors, in particular the US. Number of printers also big growth over the last years and also expected. For example, we expect total number of printers being available in 2027 of 8 million, while it was around 1 million in 2018. When looking in particular at industrial AM systems, important to mention there that, again, the EU is an important player with market share of around 30% of the total AM industrial systems sold in 2019, with better performance only by the US with 35% market share. So what we can see here is that there was an important growth in the overall AM market. Very important growth expected for the coming years, but these big trends, let's say, do hide some very interesting peculiarities in the market. And by then I mean that we have in the additive manufacturing market well-deployed solutions. That's clear, but this is a really highly dynamic market, still very growing market, also with applications, solutions that are now at quite low TRL again. So you really have this high dynamic in terms of solutions being deployed industrially, but then new solutions emerging, lower TRL that needs co-development with activities from facility centers in cooperation with industrial actors. So a lot of different technologies, materials being available, a lot of connections with other digital technologies, other technologies like robotics and so on. So you have this highly dynamic market with solutions being developed very in a fast-moving way. Let's really dive into these different segments to illustrate that diversity. If we look at the application areas, it's clear that you have in some application areas a quite high deployment of AM solutions already. And this is some information from the Wohlers report, where you can see application areas, sectors where additive manufacturing solutions are the most deployed: automotive, consumer products, electronics, aerospace, medical, dental. These trends are to some extent confirmed by the searches made on the 3DP PanEU platform, where you do find again these sectors in different order, of course, because here it's also more about demonstration activities, so lower TRL, but still same sectors coming back. But I think what is very important to mention here, and this is based on desk research and on analysis of the 3DP PanEU data, is that you have emerging segments where additive manufacturing solutions will be key in the future, but they are not yet fully deployed. We have listed a few examples here that are both within the sectors where additive manufacturing solutions are already well deployed, but also outside. For example, and we had examples already through Renotec, for example, construction sector. We expect big growth of additive manufacturing in the coming years. ICT industry with some specific segments, sporting goods as well, the overall repairing maintenance using additive manufacturing, but also segments in automotive, for example, with structural components where additive manufacturing will be more and more used, also functional parts for spacecraft in the aeronautics and space, and some specific segments in healthcare and medical devices. Same kind of reasoning can be said for the materials used. We know that in Europe, metals, plastics, polymers are well deployed, quite often used already. But you see new materials, or at least materials that will experience very high growth in the future. Again, we have listed a few of them based on desk research and the 3DP PanEU data. We can list natural polymers, hydrogels, and more generally 4D printing, also mentioned by Noraf Renotec, composites mentioned by Unibo, precious metal for component integration and ICT, ceramics as well, and all the aspects of multi-materials. So now if we take a bit more distance, let's understand why 3D printing solutions, additive manufacturing solutions, have experienced such a high growth in the past and is expected to be more and more deployed with new solutions, innovative solutions being deployed. With really an helicopter view, it's because additive manufacturing has and will have a very crucial role in instrumental transitions in the manufacturing sectors. And these transitions, the role it can play for these major transitions. It relates to the smart transition, so smarter manufacturing, green transition, more sustainable manufacturing, and a more resilient and competitive manufacturing industry. For all these transitions, additive manufacturing has a lot to offer, free from design, material, energy savings, lightweight, circularity in terms of green transition, and many other advantages that, of course, you know well. And why is it so? And here I would like to point out one really key and instrumental characteristic of additive manufacturing is that it's really some kind of integrator between data on one side and tangible products on the other side. So it can really integrate advantages from a lot of aspects like predictive maintenance, but also end of life, free from design and so on, to really contribute to these very important transitions. So now one might wonder, given all these advantages, why additive manufacturing is not even more deployed. But it's quite simple. It's because when you take the perspective of an SME, especially a downstream SMEs that do not know exactly what are the advantages of additive manufacturing and how to really uptake additive manufacturing solutions, there are a lot of barriers that remain. I will come back to these barriers later, but they do relate to a lack of awareness, still technology deployments to be made, especially looking at reducing costs, improving reproducibility of the parts, so a more automated process, integration of post-processing, also need for standards, certification, and other barriers that will be disclosed later. So taking into account these advantages, the remaining barriers, we were able to put forward some key innovation areas that we think will be highly demanded in the near future. They are already now highly demanded by SMEs and in the field of demonstration activities. So these are innovation areas that can be grouped under key categories, like first, sustainability, recyclability of the AM solutions. So there are specific aspects put forward, like material research, design improvements, recycling capabilities. Also, lighter components related evolutions are very important. Other innovation areas, but I will not have time to go into details of all of them, but that can be associated to a more automated AM process, larger series as well, fully really realizing the Industry 4.0 paradigm, so linking up, integrating digital technologies into this additive manufacturing process, also linking up more intensively with other technologies, robotics, and so on, and working highly on higher quality materials, hydrogels for the printing, ceramics, precious metals, and aspects of multi-materials. So a lot of innovation areas. Others will emerge in the future, taking into account this integrator role that can play additive manufacturing in the future. So this was a brief analysis on the demand side. So it's clear that it's fast moving, segments that are well deployed, segments that need to be further deployed in the future. So now let's look at what's there in terms of equipment and expertise in the field of demonstration activities. So for that, we can have a look at the characteristics of the equipment. And here it's about the 3D printing equipments that are available in Europe in our facility centers. We have data for the Europe in total, but also we have analyzed data for some specific countries. Here we listed 6 countries in particular. What we can see there is that it's clear that there is good and high coverage of, let's say, so we have a lot of printers able to address needs associated to some key materials already well deployed in Europe, metal and plastic and polymers. So it's obvious in Europe and in all the countries that are described here. However, what we can see is that when we think about these emerging materials that will be more and more demanded in the future, it's clear that we have less and maybe not enough equipment in some countries able to print and prototype parts in these materials, like ceramics, natural polymers, precious metals, hydrogels. So there it's an attention point, and it really illustrates that we have much less equipment for that. Very important first to connect and make available all these equipment in Europe, but also think about, of course, investing timely in these equipment when it will be really needed. Now, in terms of materials and technologies, so now let's go to the technologies. We have data on the technology that are associated to the 3D printing equipment, and it's quite aligned with the previous trends that were mentioned. It's clear that in Europe we are overall strong in metal and plastic associated technology, so a lot of equipment registered on the 3D panel data are based on material extrusion and powder bed fusion. Much less equipment based on direct energy deposition and binder jetting, so attention point as well there. And another type of analysis we were able to conduct is to look at, in these facility centers, what were the application areas that were targeted, let's say, by the equipment. So of course it's rather theoretical, because an equipment can be used for a lot of, if not all, application areas in theory. But we asked, okay, with this equipment, what type of parts are you prototyping for which type of application area? And there you can see it's in line, of course, with what were the key trends in the demand side. But what is important maybe to point out is that you can clearly see some differences across countries, and we have a table on the next slides that really detail these differences. And these differences do reflect the economic structure within the country. So, for example, many printing equipment used in Belgium for medical and healthcare, many equipment in the Netherlands used for parts associated to production technology. Other country-specific trends can be let's say, put forward based on this slide, but I will not have time now to go into the details. Another analysis we were able to make is to see what type of size are the printing equipment in Europe able to cover. And you can see that, and it's not a surprise, many equipments, printing machines are able to print rather small, medium sized parts, but quite a few of them are able to cover needs associated to larger parts. It's especially and relatively, of course, true in France and Germany, at least based on the data we were able to gather. But it's relatively less the case for the Netherlands and Poland, where we do observe quite a high number of equipment able to address large parts. And these equipments are associated to the construction industry in the Netherlands and furniture industry in Poland. Here again, more details at country level. We do also have, and please look at the report for more information, we do also have information about the brands of the equipment. And you can see here The top 3 brands are HP, WASP, and EOS. So an important role for European companies as well there. And for your information, we were also able to really go at the level of the models for each of these brands, and this is information available in the report as well. Software, not a big surprise there as well. Maybe an important point to mention is that we do observe some kind of maybe lack gap in terms of software for advanced materials. So an important also point to be taken into account. These were for the printing machines themselves. Now, if we look at the services offered by facility centers, we see that a lot of facility centers obviously offer prototyping services, also product design and modeling, and different testing. Other important aspects are technical studies that are also highly demanded by SMEs. There, what I would like also to point out is that technical training is something very and more important for SMEs, as mentioned also by your experts. In SMEs, you need also to have the skill to use additive manufacturing process in a good way. Technical training more and more important, and there may be a relative lack at the supply side to be also taken into account in the upcoming years. So what can we conclude now based on this analysis of the supply and demand of demonstration services? In a nutshell, we can see clearly that for the basic, let's say, standard needs, so metal or plastic-based 3D printing parts, rather small size, in application areas that are, let's say, well developed already, there is clearly a growingly and adequate national coverage on the supply side. But there, and this was mentioned also previously by other speakers, still it's important to avoid unnecessary investment duplications across a country, but also across Europe. Now, for more emerging and complex needs, it's clear that we can see some gaps that can be, let's say, covered quite rapidly eventually. But there it's really important to have a smooth cross-border cooperation and to ensure access by SMEs to these specialized facility centers that are experts and do have equipment in these emerging and complex, associated to these emerging and complex needs. In addition to that, it's important to propose supportive actions for these segments that are strategic. We identified some of these segments. As mentioned, this is a fast-moving industry, so this is an exercise that will have to be updated quite frequently. But you can see here some, let's say, technical areas where we think supportive actions should be put in place because the demand for demonstration services will be very high in the future, and we do observe that the supply of expertise and equipment is still relatively lagging behind. So very important there to have access to specialized facility centers, but also to make sure that the expertise and equipment are more and more available in the near future. So in red, you can see some key segments where it's really important. So some segments in medical and healthcare, aeronautics and space, I already mentioned. Also segments associated to a more automated process, and in particular integrated post-processing. Segments related to multi-materials, precious metals for ICT industry, and so on and so forth. They are all mentioned here, and I will get back to them if I have time very quickly later, but please have a look. Please comment also. If you see some missing segments, let's say, we can still integrate that into the final report. Here, and I will have to be quite brief because I see that I do not have much more time left, but if we now take the perspective of an SME, there are not only gaps associated to the technical developments that are still needed in the future, but you do also have very transversal gaps that need to be mentioned and that we were able to identify based on the overall analysis of the AM market. We have mapped these gaps here. These are the gaps mentioned in red, taking into account what we can describe as some kind of innovation sequence for an SME, of course, applied to additive manufacturing. So it's a sequence of steps that will enable an SME, and in particular a downstream SME, to understand what kind of solution can address the needs of the SME and to uptake that solution using the services of the innovation generators, universities, facility centers, and innovation disseminators. What are the key remaining gaps in the additive manufacturing landscape? So first, we need more tailor-made information about possibilities, limitations, and implications of additive manufacturing solutions. A lot of SMEs do not have yet a clear view of what can mean for them going additive. Then a bit further in that sequence, even SMEs made aware of these advantages, they do not have a clear view, especially downstream SMEs, on which exact technical solution would be relevant for them, and what would be, let's say, the technical roadmap needed to implement that. So they need additional guidance, and their facility centers have also a big role to play. Finally, we see that a more facilitated and smooth access to demonstration expertise and equipment is still needed, and especially when we deal with specialized services, as demonstrated earlier, and especially when these specialized services has to be accessed outside of the region, outside of a country. So it's about really having access to demonstration equipment and services that enable to test before invest. Then once demonstration activities are positive, successful, it's about uptaking it. There are still gaps in terms of skilled labor force, difficult to train the current labor force or find relevant people to really work with the additive manufacturing process. We do still need more SMEs-inspired regulations to facilitate uptake, also harmonized standards to facilitate uptake and deployment. So a few key gaps still identified, and for these gaps, we have elaborated some recommendations. I will briefly go through these recommendations, which are detailed in a report that will be, of course, made available once finalized. So if we look at these gaps associated to the lack of awareness and lack of technical guidance for downstream SMEs, what we suggest to organize is more activities and events where SMEs could be really inspired by counterparts, testimonials, examples, where it shows what was implemented, what were the impacts. These activities should be really challenges, solutions driven, and it should not be one-size-fits-all activities, but really focusing on counterparts, testimonials, so that it's really inspiring for SMEs. Second, in the same logic, we think that toolboxes or studies should put forward examples, concrete examples, comparing additive methods with subtractive manufacturing methods, especially for larger series, for example, to really raise awareness. In a subsequent steps, so once SMEs are made aware, to really address the lack of technical guidance that can be there sometimes, we do suggest to have challenges, solutions, activities being organized across regions, so at a European level, to really benefit from critical mass and have SMEs being able to put forward a challenge they have, and have then facility centers providing some technical guidance on what can be really the solution or not using additive manufacturing, and provide some kind of guidance on possible technical roadmaps for that. These are a first set of recommendations described much more in details in the report. Now, in order to address the problem associated to the need to have a facilitated connection across regions, what we, and especially for specialized services, what we do recommend is to organize, I would say again, and quite frequently, regular and comprehensive monitoring at European level and associated matching, but I will let Wim discuss that more in details, of both the demand side evolutions and the supply side availability, to be sure that there is a full understanding at a European level of what are the key emerging trends and segments, and to what extent are these segments covered or not by the expertise and equipment on the supply side. Of course, we can build upon existing initiatives like the Vanguard Initiative 3DP pilot, and more generally the thematic smart specialization platform, but also looking really at the monitoring of the deployment of technologies, the ATI project from DG GROW as well. To, let's say, have a smooth access across regions, what we do recommend is to continue and strengthen support for interregional collaborations, and in particular the Vanguard Initiative 3DP pilot, for example, to really make sure that there is this connection facilitated across regions so that SMEs can have access to these specialized centers where they can test and validate it solutions. A lot of barriers associated to that, they remain connected to funding instruments. So when it comes to funding instruments for activities at TRL 5, 6, 7, 8, what we do recommend that, because there are instruments available, but there are still some gaps, and we do recommend in particular to have structural funding solutions being made available for cross-regional demonstration projects for all the reasons we explained before. There, some initiatives are being developed, like I3 by the European Commission. We hope it will indeed be a solution to these needs, but at regional level also additional work could be done to make sure regional funding could also serve cross-regional demonstration projects. We do recommend also to have particular funding support for supply chain driven projects, so really to ensure that we do develop impactful projects in a supply chain, projects that do address the needs of OEMs, for example, involving tier 1, tier 2 suppliers, so that we do build really projects that will have big impacts because they do address needs of lead companies in the supply chains involving the suppliers, for example. We do also recommend to sometimes, and for instruments at TRL 567, to target specific segments. This is done in innovation areas, research and innovations areas, so sometimes lower TRL, but it should be done also sometimes at higher TRL. So really targeting areas that are deemed as strategic, emerging, and where gaps have been identified. We have listed some of them here, which were based on the tables presented previously. Now, looking at the overall additive manufacturing innovation sequence that was presented previously, very important points, and this was reflected in some discussions, previous discussions experts put forward previously. We should avoid really any silos within the additive manufacturing innovation sequence. It means connecting really innovation generators, university facility centers, with the innovation absorbers, let's say, the downstream SMEs. Of course, we have to build on existing initiative to do that. There was an initiative in Austria presented previously. There is the EM platform at European level, the Vanguard Initiative 3DP pilot as well. And punctual initiatives could be further developed for that, like initiatives to answer smart matching. So, for example, these challenges solution camps, connecting really actively downstream SMEs with facility centers, structural matchmaking tool. Wim de Kinderen will present what we have done in that respect. Foresight analysis studies also looking at the matching between the really low TRL activities, but also the needs of the industry, and to be sure that there is a match there and to adapt if needed the research, and overall some really structural channels that do make sure that these feedback loops between industry needs and lower TRL research is facilitated, as is ensured within the additive manufacturing innovation sequence. Some recommendations associated to framework conditions. Will not dive into the detail. No, I will just finalize with also a very important aspect. We discussed a lot the additive manufacturing innovation sequence and the connections that are needed within that sequence. And broader than that, it's more and more important to connect the additive manufacturing community with what we can call partnering innovation ecosystems, because we have seen that a lot of solutions will require cooperation between additive manufacturing communities as well as other communities associated to digital technologies, green technologies, and so on. So very important to launch, support initiatives that do address, do avoid that there are any silos between these big communities of innovators. So we have listed here again a few possible recommendations with networking, matchmaking related activities, including online matchmaking tools. We would like also to work on that in the future, as Wim will put forward. Foresight studies as well, maybe to find these segments that are really at the frontier, at the crossroads of different innovation ecosystems, so that can be less known also by these innovation ecosystems, and also do target innovation projects, do support these innovation projects that are at the crossroads of various innovation communities, let's say. Of course, doing that, building upon existing initiatives that are there, like the S3 platforms, and maybe using, hopefully, new tools from the European Commissions, the European Innovations ecosystems, Euroclusters, and so on. So that's it from my side. Apologize for having taken a bit more time, but apologize also because I had to rush a bit. But if you have any questions, please, of course, do contact me and I thank you a lot for your for listening to the presentation. Thanks a lot.
Big thank you to you, Jean-Francois, for taking us through your presentation and for sharing the interesting information based on the analysis which has been conducted by you over the past couple of months. So big thank you to you. Indeed, if there are any questions, please feel free to address them to Jean-Francois. Indeed, keeping an eye on the time, I would like to quickly move to our final speaker for today, Wim de Kinderen from Brainport Development, a colleague and also part of the project consortium, who will be giving you an insight into the future matchmaking possibilities under the 3DP PanEU platform. Having said that, I'm going to pass the floor and the microphone, so to say, to Wim. So please take it away.
Thank you, Tim. Allow me 1 second. I'm in a hotel room and they're calling me. 1 second.
Yeah, that's fine.
Okay, with the risk that they will kick me out, thanks a lot. And Tim, can you confirm that you see the screen and you hear me?
Yeah, I can see it.
Excellent. So an incredibly rich project, if you ask me. My name is Wim de Kinderen, and as Tim said, I'm a colleague at Brainport Development who has been involved in the project as well. A rich project where at many occasions you have heard the word platform and a matchmaking tool. This is what this is about, and I'm about to explain you that and also how we are going to look at that tool in the near future. How does this work? Voila. This is not my COVID pass, and this is also not the QR code which gives me access to the menu for the lunch that I will be having after this conference. But this is the easy access point to the 3DP PanEU Gateway, the search engine and matching tool that we developed in the course of this project, and which is the key element in everything we did. Why were we so convinced that we need such a tool? We are the 3DP PanEU partners, are a group of organizations which are collaborating already for a longer time on strengthening the value chain in 3D printing in Europe. And most notably on the aspect of bringing the innovation quicker to the market and support the deployment of additive manufacturing industry. The concept of facility centers is key. We believe strongly in their added value and the acceleration power. I think it has been demonstrated in the previous presentations clearly what this added value is, because SMEs can make use of the infrastructure that is too expensive for them to buy themselves, and on top, as was indicated by Profactor as well, there is services. There are people that can help the companies in developing, validating and testing their new products and services. But of course, you need to find that facility center first. It's very nice to have this idea, but if you don't know where the facility centers are, there's nothing much you can do. So this overview and this transparency of the existing offer in Europe is missing. There are regional initiatives, such as was demonstrated and mentioned, the Austrian one, but a complete overview of the European offer is missing, and that is what we wanted to fix. That is also what we wanted to fix in the shorter term, because we do still have the ambition to steer future investments, upgrading existing infrastructures and building new ones in the directions of the future industry needs, as were clearly shown by Jean-Francois in the previous presentation. But first, it's about using what is there. And another motivation, which was maybe a bit on the background, but nevertheless still there, in stimulating these contacts, but also the contracts between facility centers and SMEs, we also want to help facility centers in diversifying their income base, basically. So this is the homepage of the 3DP PanEU website, as you have seen it before. with the tool as its main feature. And it's quite a success, as has been mentioned before today. We have more than 300 active facility centers with a full profile on the platform. Now, how does this work and what does a full profile mean? When you click on the registration button on the homepage, you arrive on a page like this, which is quite familiar for many websites. You can create your own account. And then in the next steps, you add the equipment you have at your disposal, the offer towards companies, which you can indicate here, which is quite detailed: the brand, the number of machines, the model, the size you can produce, the quality of the production, all the things which were at the basis of the analysis that Jean-François showed in his study in the previous presentation. And then next, you can equally, and not in the least less important, you can equally describe next to equipment the services that you have to offer to support companies in doing that. So this is interesting. It's also quite a big success since we launched it in March last year. We have more than 1,000 pieces of equipment registered, equally more than 1,000 services registered by the more than 300 facility centers. But at the end, you see this man on the picture who is waiting. And that is basically what facility centers in the current version of the tool have to do. They have to wait till an SME contacts them, till an SME gets on the webpage, searches for what they need or what they think they need, and then reaches out to a facility center. And only at that stage, the facility center can engage into a conversation with the company, which hopefully leads to a real collaboration. So we can and we need to do better. And that is why we are currently working on the tool 2.2 version, which is the gateway, the 3DP PanEU gateway, which has the explicit ambition, and this is not a wish, we are working on that today, to go from a search engine to a real proactive tool and an interactive platform with a double motivation. Because if our goal as a consortium is to strengthen the value chain, and you consider the digital tool as your key instrument, it would help us quite a lot if every player in the value chain would actually be integrated in this digital tool. So instead of having facility centers wait for companies to contact them, we need to allow all value chain players to proactively reach out to each other. And like that, we go from a one-way communication tool to a multiple-way interaction instrument. And if we can ensure all of that, we can also ensure in a better way the post-project life of the platform, which is coming nearby, because this is an incredible project, but it's ending around Christmas time. And we do not want to have the same situation as some other projects have, which is that a good instrument slowly dies after the project. So we are looking at a new host to be the guiding, driving partner for the gateway, which in Platform Live means that we have to enhance the value of the platform and we have to add additional functionalities to make it more attractive for such a future host. And to do this, we also have already partnered with a real expert on this. We have an expert on board in 3DP PanEU, to be very clear, but we have partnered with Qualified, who has as a full-time daily business the design and the operation of platforms such as ours, and that is the Qualified company from the Netherlands. So when we are saying we need to integrate all other value chain players next to facility centers, that is what we have done today. So if today you go to the registration page and you make your account, you come to this page. You will see that you have to indicate which type of organization you are if you are not a value chain partner. And you also have to indicate, in that case, which country and which region you are from. Because indeed, this is already preparing for the future. When I'm talking about a new host for the platform, we are primarily looking at the Vanguard Initiative, which is a membership-based association. So for facility centers, we are very clear. For the next time, and at least for till 1 year from today on, all facility centers in the whole of the European Union can continue to register new accounts, and we very much stimulate everybody to continue doing so. But for other value chain players, the registration possibility is limited to the geographies which are participating in the Vanguard pilot. If you are not based in one of those regions, there are other possibilities through qualified, but that will be explained in that case. Because indeed, Jean-François has also been mentioning the Vanguard Initiative pilot project. That is one of the 7 large-scale demonstration projects within this network of industrial regions. And this is a membership-based association covering 32 regions, so quite a few regions today and still growing. So that will give ample opportunities for companies and other value chain players to be part of this. Enough talking. How does this work in practice once you're there? Once you are going to the platform and looking for a solution? I have noticed with previous speakers that the voice goes down when the video is playing, so I will tell you what you will see in a few seconds. On the left-hand side, you will see that you can freely search the database and click on an individual organization, after which you see the fully detailed profile which corresponds to the equipment and the services the company is offering, and you can get directly into contact. On the right-hand side video, you will see that you can have very dedicated searches, such as going for specialty offers regarding metal printing, which gives you a whole series of results, 169 in the current database to be precise, after which you can also focus in additionally on certain countries, because even in an EU-wide database, distance and proximity, of course, is also is a reality. And this will actually also be very interesting in the future analysis of the platform to see what a feasible distance for an individual company is to work with a facility center which is not located just around the corner. So I will run the video now. Voila. And in a similar way, you can also look for detailed services offers, for example, regarding post-processing. And all of this we offer on a regular laptop, but the tool is also made to fit very well on your mobile phone, so you can do these searches everywhere you are at whatever time. This is tool version 2.0, which is the current reality. So everybody who goes to the website, every player in the value chain can register, making use of all the opportunities there are. and this two-way communication is already a possibility today. We are also looking at the next version, the 3.0 version, which is going to extend the current search engine and matchmaking tool to a larger series of technologies, advanced manufacturing in general, even kits. Because 3D printing, as was also outlined by the study presented by Jean-François, is not a standalone technology. On the contrary, the most interesting results are being booked when you are combining different technologies. So that's why we want to offer the room to value chains of neighboring technologies, looking first to other Vanguard Initiative pilot projects which are interested and have indicated to be willing to develop this with us, such as nanotech and artificial intelligence, for example. This is the platform has been designed from the start that we are able to do this extension. Because at the core there is the database which allows full interoperability and which allows a customized design to allow to service for the best way these new other technologies. What we can also do, and which has been integrated in the design from the start, is the possibility to create links with other existing initiatives. For example, all the players in the Austrian platform that we have seen shortly before today can easily be linked to our gateway. There are possibilities to value this previous initiative and to assure that the investment done in such an initiative are not thrown away. We can easily integrate this and also make sure that the visuals are integrated into your own website. So we will not force every company in the European Union to discover a new website. We are fully able to integrate the database and the visual translation of that, so the search engine and the matchmaking tool, into the communication channels which are already known by the companies in your region. So that should facilitate the use to a large extent. So we are basically ready to do this, and we hope that you are too, because we can do this in one single click. As said, we are partnering with Qualified, a Dutch company, which has already this on offer for other technologies, as you can see here on the screen. So what we can and will do is to create a dedicated Vanguard community, making these cross value chain possibilities a reality. So this is my last slide to finish up. This tool semi-automates the process that people like us here are doing on a daily basis in a rather traditional way, which is time intensive and therefore also cost intensive. This tool is giving an additional offer which makes possible new kinds of collaboration, more ad hoc, maybe also more short term. It doesn't need to be multilateral, it can also be bilateral. So it's adding to the traditional process of coalition building and project development. But we don't want to throw away this way of working. We do count on 3D PanEU Gateway to signal interest from companies and trends, such as the ones which we have already analyzed through the report that was presented just before me. So this will allow us to develop project building in a much more industry demand driven way as we may do it today. So I invite everybody to sign up to the platform, take a screenshot or point your mobile phone to this slide, and we hope to be seeing you in the platform in the next time. Thank you very much.
Thank you, Wim. Thank you for presenting this information and for showing us some images of the new Gateway platform. Indeed, we've been working on not only realizing the platform, but also looking at how we can add value through the platform. And we really think that with the steps that have been presented by Wim, we can generate additional added value on top of the strong foundation which we've already realized. This was the last presentation for today's program. We hope that we've been able to present you with interesting content, relevant content, and to give you some more insight into the 3DP PanEU project, what we've been doing over the past couple of years, and what we have to look forward to. In any case, it's good to point out and mention that we will be uploading some of the materials used today to our project website, so please keep an eye out there. You'll be able to find some draft versions of the report from IDEA consultant Jean-François. And of course, we invite you to take a look at the new Gateway platform, which has been developed together with Qualified. So yeah, head over to 3dppan.eu for more. That's all from our side. A big thank you to all of our guests who are with us today this morning. A big thank you also to all of our speakers who joined today and for sharing their information and their perspectives and their views. So yeah, we hope you enjoyed it. We hope it was interesting. We wish you a nice day ahead. And once again, a big thank you for joining us this morning for the 3DP PanEU final conference. Thank you, take care, and goodbye.
Thank you, Tim. Goodbye, thank you.
Thank you.
Bye. Bye.